points because it doesn't have any. So you have to decide, does it have 2 dimensions or does it have 1 dimension?
2 dimensions.
Okay, so what are the 2 dimensions?
The 2 like arrows going left and right.
So let's think of some things that actually are 2-dimensional. Like you go to the store and you buy a piece of tile. Okay. Tile has length and width, for example. Does this have length and width?
No.
No. So you would just, if you could, you would just measure its length. So I would argue it only has 1 dimension.
All right.
Is that okay?
Yeah. How was your 4th of July?
Well, it was it was not as good as last year. Last year I went and watched fireworks in Colorado and with family, and
Oh,
it's not as
cool.
much, not quite the same. I do wear an American flag shirt every year on 4th of July. It's kind of that, once a year thing that you can wear. So
Yeah.
all right, so Naomi draws a portion of a figure. Let me make this a little larger so you can see it. He wants to construct a line segment through R that makes the same angle with QR as Q. Shown below. Which figure shows the next step to construct a segment angle at platform? Okay. So let's go through the ones that it's not. It's not the ones with the ruler. So you don't use the ruler until the end. Okay. So now we got to kind of look and see, well, what's the difference between these two? So this one on the bottom here, you're swinging an arc from S to T or from T to S. And this other one here, you're swinging the original arc out here. But notice you've already have that arc here. Give me just a second, please.
All right.
All right, Merico, you there?
Yeah.
So the difference between these is that, see, in the second one, or in the first one, you're drawing kind of this arc from S to T, which is already here. So that wouldn't be the next step because you've already drawn it. What would be the next step is drawing the arc from S to T or T to S, and then going to R and drawing kind of another arc here. So I'm going to suggest it's probably this third one here.
All right.
Okay. Stella is using her compass and straightedge to complete a construction of a polygon described in a circle. Which polygon is she in the process of constructing? So I want you to count the number of vertices that you might see, like basically the like, think of this as a vertice. How many of those do you see in the
5.
there's also this one down here at the bottom.
Oh.
Okay, so I would argue, and if you start connecting them, is 6.
Yeah.
So a 6-sided polygon is a hexagon. Does that make sense?
Yeah.
So that might be something to throw on your note card, is like, number of sides. You might remind yourself that if it's got 5 sides, it's a pentagon. If it's got 6 sides, it's a hexagon. Okay, so let's go on to the next one here. Stell draws 2 parallel lines, PQ and RS, intersected by transversal KL. Which fact would help still prove the measure of angle KMQ is equal to the measure of angle MNS. So basically, yeah, this angle right here is congruent to this angle right here. That's what you have to decide here. Like, what are they? You know, and there's certain words we're looking at. Are they consecutive interior? Are they alternate interior? Are they um well, so the interior is here. Let's go through that. Are they both in the interior?
Yeah.
No, the interior is here, the exterior is up here.
Oh, I meant no.
Okay, so that one's out. Now, alternate interior means that they are alternating over the interior. Are they alternating?
No.
No, so that one's out. So now, what could it be that's next? Well, are both the angles equal to R and M? So R and M is this one. I'll put that in green here, like that, and then KMQ MNS. So is it PM or are they congruent to this one right here? You know, which green angle are they both congruent to?
Um. Uh. The top one.
The top one, because those are vertical angles and then alternate interior angles. So it looks like this one is correct down here.
All right.
Yeah. All right, Merico, so let's go to the next one here. Is the goal to we got to get through all 15 today, is that right?
Yeah.
Okay. Anything else you need to get through today?
No, not really. I had another assignment, but it's just like kind of my own thing. It's
Okay.
not like math or anything. Uh it's just like information about the final, and I just have to submit it so then they know I like read it.
Okay. Okay. So we've done this problem a few times. Triangle JOY is moved right 3 and down 2. The the they're over there. Okay, so the triangle we talked about, you move it right 3. You know, every point goes right 3 and then down 2. Okay, right 3 and then down 2, right 3. And so you've got this new triangle here. And they're asking you about, well, what about this line to this line and like this one to this one? And what do you, yeah, what like visually, what do you see? Let me try a different color here.
They're parallel.
Parallel. There you go. That's it. So you got America, you got to remember that like this is all the questions on your final are gonna be questions we've already seen. We talked about that thing at the beginning that you need like a catalog of these things or a memory, a way to
Yeah.
you know, and that's all that's happening here. So um when you look at this problem here, it says that it's translated -2 + 3. Okay. So then you have to first figure out those new points. So you got to go, you know, subtract 2 from the X, add 3 to the Y. We need to get those first new ordered pairs. Then we'll do the rotation 90 degrees about the origin. So could you give me those new ordered pairs whenever, just for the first one, for the right 2 and then up 3.
Sure.
Good.
-7. -7, 4.
Okay, keep going.
And then -4, 5.
Okay, -4, 5. Yep, got it.
And then
Next one.
-3, 4.
Okay,
Then -4, 3.
yeah. Okay, so good news is we got them all here. Now, the next transformation is 90 degrees about the origin, counterclockwise. So let's see here. Let me go grab that one. It's down here at the bottom. All right. So let's see here. All right. So counterclockwise, that means that XY becomes -y comma X. So you probably only need to manipulate one of the points to get the one that's down here in the list.
All right. It'd be 4, 7.
Yeah. Now is that in any of the ordered pairs there?
And then 5, 4.
Okay.
Oh, the
So
first
see
one.
how, yeah, so you could check them all, but if you get one that works, you've done it. Like that's enough.
All right.
And I mean, I'm happy to help in the final. I don't know if that's an option, but we can, we can go through and work the problems out like we usually do. Um, so you got to look at this new image here and decide like, well, what's happening? What is happening? Like, is it you know, is it a translation or is it and like what's going on here to get you to where you start with the one on the left to get to the one on the right? And it's like it's not the obvious one. Like the obvious one is it just reflects over this line right here. That's kind of what I'm seeing as the actual one. So we got to follow the ones that are here. So the first one is it's going up 2, and then it reflects over the line x equals 1, and then it rotates about the origin. So rotating about the origin would move it like it would become more vertical. I don't know if you can see that.
Yeah.
So that's a problem for the first one. So the second one is if you move down, if you move down 2, well, I'm sorry, it's a 180-degree rotation. So to get for the final, let's look at this last part because I think that's to get the last part here, it actually needs to look something like this. Like it's got to be something more like this right here. So how do we get that? Like how does that happen? Well, it happens by reflecting over this line y equals 1. Because it's got to somehow like do this. That's the line y equals 1. And so that means to get it to down here, so there's a 3-unit difference there. It means that there needs to be a 3-unit difference there.
Yeah.
So we actually need the one that goes up 2, and then y equals 1, and then the 180. So which one would that be?
The bottom.
The bottom one. You got it. Good. It's no. Okay, so I'm gonna Merico put the next one in here. All right. If Eric reflected parallelogram across the x-axis, and angle A is 125 and angle B is 55, what is the measurement of A prime? The question is, does a reflection affect the angles? Like you can draw any parallelogram you want, and it's reflected across, the x-axis. Like, do the angles actually change?
No.
No, actually, that's a terrible drawing. Yeah, they don't change. That's good. It's good. So no, the angles don't change. So the new angle is exactly the same as the previous one there. Is that okay?
Yeah.
All right. All right, so let's go to the next one here. Yep. Maybe that is the last one. I can't tell. Well, no, let's try this one. All right, so triangle ABC has been translated. Create a triangle A prime, B prime, C prime, and they're both 32 degrees. They're both 70 degrees. Which posture of the true triangles are congruent? So you have to decide here, are they giving you information about three sides? That's what SSS is. Or are they giving you a side, an angle, and a side? And you're just looking like that's an angle, and that's a side. Or an angle, side angle, or is it angle, angle, side? So are they giving you information about three sides, two sides and an angle, two angles and a side?
Two angles and a side.
There you go. So it must be S. That's AS.
Wait, you
So
said
that might be
two.
another thing to prove congruence. Might be a good thing to put on your note card here. Congruence is either, and there's four of them, it's side, 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 angle, side angle, or angle, angle, side. There is no ASS theorem. It's, kind of a joke when you're 15 taking the class,
Yeah.
right? Yeah, I don't know. I mean, I think it's funny, but you got to be careful what you say nowadays. I mean, people are very sensitive. So yeah,
Wait, didn't you say it was there's two angles and a side?
yes.
So
Sorry, there it is.
yeah, I was just like,
Sorry. Yeah, I am not in my right space right now, but I'm trying to. Yes, I do make mistakes. So yes, please question me if I, say it's five and then I end up circling four.
all right.
All right.
Just
So
want to make sure.
we got through nine here. So if you want to queue up a few more questions.
Gotcha.
Proofs. Dang it! Wow, you got. All right. So what do we got here? We got proving. Looks like we're proving. We got two triangles. This is one of those like, here's the triangle, here is the other triangle, and these lines are probably parallel, which means that these angles are congruent, and that angle is congruent. Share an angle that's congruent, like that. So we got to go figure out what's going on here. So there's the givens, and then there's the right angle, and so what is two and what is three? So there's no alternate interior sides here. Alternate interior angles are congruent. So that would be like if they were cut by a transversal, okay, and they were on the other sides. But these are like same side. So it's definitely not these two. Okay, so it's definitely the corresponding angles are congruent. So now we're up to the triangle sum theorem. Triangle sum theorem. So the triangle sum theorem is like the three angles have to add up to 180. So if they give you two of the angles, you have to come up with the third angle. So
Yeah.
that is, that's the base angle theorem. I don't know what that is. That might be something to do with I don't know what to do with that, but that is um triangle sum theorem is the answer. I have a lot of lower back pain today.
All good.
Yeah, trying to get it worked out. It's really bad.
What about the
Uh,
yoga?
Going to yoga tonight, hopefully, but man, it's bad. I don't know what I did, but
You should go to a
yeah,
chiropractor.
yeah, that's on the list too. It's like it's awful right now. But
Yeah,
so whenever you're ready, if you want to send over the
just
next
did.
one. Yeah, so I mean, just to summarize there, if you have two of the three angles, it's called the no choice theorem because you're guaranteed to get the third.
All right.
And we know this. I mean, there's examples of this in real life. I mean, yeah, there's examples of this in real life where it's like if you didn't do it and your friend didn't do it, then it must have been the other friend. Or you can think of a million examples where there's only three possibilities, and yeah. So, all right, looks like you put another one here in the chat. Hopefully not all. Oh, you put a bunch more in the chat, didn't you? Okay.
Yeah, I would just put the rest.
Thank you. Let me since I got this one up, we might as well just go through and do it. So we're trying to prove that segment RQ that X equals 45. So that's 45 there. Basically, we're trying to prove that this ratio that exists. So it's that 60 and 48, 60 plus X, 48 plus 36. They like these are in proportion. So it's like 60 colon 60 plus X. Right. You see that anywhere in this answer space? It's like the smaller one to the larger one, smaller one to the larger one.
Let's see. Like one of the answers.
Yeah, yeah. And then it would be equals 48 to the 48 plus 36. Oops. It's like the part to the whole kind of thing.
Mm,
Smaller to the larger equals smaller to the larger.
would it be the bottom one?
Yeah. Yeah, you can't see that. Yeah, that's it. I'll be back in 10 seconds. We're gonna keep going.
All right.
Okay. Okay, so let's go back to the order here. Next one I saw here was this one here. Dilated by a scale factor of 2. So what does that mean if it's dilated by a scale factor of 2? Is it getting bigger or is it getting smaller?
Smaller.
2 means bigger. So we that's one of the things that goes in your notes. K greater than 1 means it's getting larger. 0 less than K less than 1 means it's getting smaller.
Oh.
Okay. So now the point that it dilates about is important. So that point right there is the dilation point. So it means that the distance from here to B is 1. So the new distance is 2. From 0 to A is 1. New distance is 2, like that. And then this one over here, C, it's going to go out 2 more. So we'll just say roughly there. So now you got to look at all the answers and decide, does any of this like, B prime, D prime. I mean, here's B prime. Here's D prime. You know, what do you think here? Like, does it run through 2, 2?
Yeah.
So it sure looks like that. Now, is it shorter or longer than the original?
Longer.
It's longer. Yeah. There you go. So like, again, this stuff I'm writing over here up to the side, that's really good stuff for your note card.
All right.
Okay. So DF is dilated from the origin. So from the origin here. All right. And oh, they're actually giving you the new points of D prime, F prime. Okay. So here's we need the original ordered pairs. The original ordered pair of B and F. Can you give me those? The ordered pair for D, please.
4.
0, 4. And F is 3, 2. When they go 2, it goes to 0, 10, 7.5, 5. So how do you go from 4 to 10? Like that's the question. Like, what is the multiplication to go from 4 to 10? Is it 0.5, 0.75, 1.5, 2.5? How do you go from 4 to 10?
2.5.
2.5, yeah. Now, does that work over here? Is 3 times 2.5, 7.5?
Yeah,
How about 2 to 5? Is that,
yeah.
so there you go. There's your answer. All right, so question 14, decide whether the triangles are similar. So you have to find the missing angle in each of these. And we already talked about the sum of the angles is 180.
Oh, all right. Let's see. The first one would be 65.
Okay.
And then the next one would be 33 or
Nope,
no.
they got that up to 180.
Let's see. Calculator's being weird. Hold on. Oh, 66.
So are the angles the same?
No.
So they're not similar. So all the angles have to be the same. So if this, again, another thing that might go on your note card, maybe the sum of the angles in a triangle is 180. Similar triangles, you either need AA, SAS, or HL. So AA is really AAA, but it in a particular one, it's just the 3 angles. So
Yeah.
all right. Anything else you want to cover today, or can we cut it a little short for 11?
There was one more. It was number 11. I
Okay,
already,
let me look
yeah, I already,
for it. Can you tell me what the problem is?
it was the figure below shows a quadrilateral A, B, C,
Oh, there it
D.
is. Yeah, there it is. Okay. There it is. Okay. So let's go through this. DBC, B to B to C, and BDA, BDA, are those vertical angles?
Uh, yes.
Yep. Vertical angles meet at an X. Those are vertical. They're actually alternate interior. So they alternate over this transversal.
Oh, that's what I meant.
Yeah. So now so we know A is out. Let's go to the next one here. Triangles ABD, ABD, so that's this one up here, and CDB, this one down here, congruent by SAS postulate instead of the SSS postulate. So they do share a side, they do have an angle, and they do share a side. So they're actually congruent by the SAS postulate. Let's see what it says in the proof here. Does it say SSS somewhere? It does right there. Okay, so I believe it's this one right here.
All right.
Any questions on that? Either way.
No.
All right, so what's the plan for tomorrow? I mean, what are we gonna work on? Because we got a lesson tomorrow, I think at 7.
All right. So the thing about tomorrow, let's see. So it's like the assignment's called segment 1 exam combined. And I have to turn in all my other assignments to do it. And I just did. So they have to check it over. And I'm not really sure if it's like what is it called? Like a test or, you know, I'm not
Okay,
sure if it's like a test or a quiz, just to like see how I'm gonna do. Cause I have to go and do my finals like at a different school on the 7th. So
okay,
I'm not really sure what they're doing, but I know I just have to go test at that time at like 12:30. So,
okay,
and they're allowing the flashcards. So,
all right. Well, I mean, you've seen all the questions. There's nothing, you're not going to see anything new.
yeah,
So um, but we got a lesson tomorrow scheduled. I mean, we're happy to go over whatever, or you tell me what you need.
probably just study or something.
Maybe look over questions again, I'm not sure. Um,
Yeah. Or there's one more thing I could do. There was this quiz I think we did a while ago. I could like retake it to get a little bit of a better score.
there you go. There's a good use of our time. So let's do that for tomorrow.
Yeah.
Okay. Well, let's go ahead and end here, Merico, if that's okay.
Yeah, of course.